Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 23rd video in the Introductory Programming in Java full course and the 6th video of Lesson 4, Looping Structures in Java. So far we've covered while loops, do-while loops, looping patterns, input validation loops, nested loops, and looping mistakes to avoid. In this video, we're going to talk about counting loops, or for loops. Let's get right into it. Let's start with our clock simulation program. I have a new version here called clock simulation counting.java. This program is an example of a nested loop that prints out the minutes and seconds in 1 hour. We'll start by talking about just the inner loop. In fact, I'll comment out all of the outer loop to simplify this. I'll leave line 14, which sets minutes to 0, so we can print it on line 20. So we have a conditional loop with initializer seconds equals 0 on line 18, while seconds less than 60 on line 19 and seconds plus plus on line 21. Seconds starts at 0, it increments by 1 each time through the loop, and we loop as long as seconds is less than 60. In the video on loop patterns, I told you that this variable role is called a stepper or counter. The variable takes on a predictable sequence of values as the loop executes. When we have or are designing a loop that is controlled by a counter, we can use a different looping structure that has some advantages over a while loop. This looping structure is slightly less powerful than a while loop, but it's more readable, which is an important goal in writing code. This looping structure is called a counting loop, or for loop. With a for loop, all of the loop control information is on the first line or header of the loop, rather than being spread out with the initializer before the loop and the updater somewhere in the loop. With a counting or for loop, the updater always executes at the end of the loop, just as in this loop. The updater is the last line of the loop. This loop will be very easy to convert to a for. Let's do that, and we'll go over the syntax and how it functions. So instead of while seconds less than 60, I write for open paren, seconds equals 0, semicolon, seconds less than 60, semicolon, seconds plus plus, close paren, and then open curly brace. And I'll delete the initializer from line 18 and the updater from line 20 because those are now part of the loop header. So what do you notice? You might notice that this loop is shorter than the equivalent while loop. All of the loop control information is on line 18, the first line of the loop. So a person reading this loop immediately knows exactly when it's executing and the value of the variable seconds each time through the loop. I don't have to hunt for maybe one or more initializers and maybe one or more updaters. So the syntax is the keyword for, and then in parentheses there are 3 parts, an initializer, a test, and an updater. They are separated by semicolons. The initializer and the test execute the first time we reach the loop header. So when we're transitioning from line 14 to line 18 in this example. If the test is true, the loop body executes the code within curly braces. And then, after the loop body has executed, we return to the loop header again, just as with a while, and the updater and the test execute. So in this example, seconds is incremented, and then we test that seconds is less than 60. Again, if the test is true, we go into the loop body, we return to the top, and the updater and test execute. So the first time through, it's initializer and test. And each time we return to the top after executing the loop body, it's updater and test. That is why it's equivalent to a while loop with the updater as the last line of the loop body. Now let's convert our minutes loop to a for loop as well. I suggest you pause the video and see if you can do it, referencing the seconds loop. Okay, did you do it? So I'll uncomment line 15, the loop header, and line 22, the closing curly brace, and I'll delete the initializer and the updater. Now I'll change the loop header to for minutes equals 0, minutes less than 60, minutes plus plus. And I'll also delete the comments that are now obsolete. What's important to understand about the nested for loops is that the inner loop, the seconds loop, is reached from line 13 60 times, once for each time the outer loop executes. So minutes is set to 0. The test minutes less than 60 is true. So we go into the outer loop and reach the inner loop header. So the initializer and the test execute. We'll then go through that inner loop until it's finished, and we'll go back up to the outer loop header. Minutes will be updated to 1, and the test minutes less than 60 is true, and we go back to line 14 again. So because we're reaching the header of the loop from outside the loop, not from the loop body, the initializer and test execute. So seconds is set back to 0, and that loop executes again 60 times. Let's look at another example, and then we'll summarize. This is the PrintWords program, but I've renamed it to PrintWords Counting.java. This program, you may remember, iterates through some text in which the words are separated by spaces. It uses a nested loop to do this. The outer loop is I equals 0, while I less than test.length, I plus plus. And the inner loop is text.char at I, not equal to space, I plus plus. Now, are these loops good candidates for being converted to a counting loop? Here's how to tell. If the loop is controlled by a counter variable, and the value that we need to stop at is available in the program state, in the variables, when we reach the loop header, then it's a good candidate for a counting loop. Again, I'm going to suggest you pause the video and look at this code and decide if either, both, or neither of these loops could be rewritten with a for. So what do you think? The outer loop is controlled by a counting variable I, which counts from 0 up to the length of the string in increments of 1. We know the length of the string before we reach line 21, the top of the loop. So this is an excellent candidate for a counting or for loop. We can rewrite that as for int I equals 0, I less than text.length, I plus plus. And I'll remove the declaration for I, the initializer, and the updater. What about the inner loop? This is not a good candidate for a counting loop because we don't know when we reach the top of the loop when it's going to end. It depends on when the next space is coming up in the string. We don't know that until we reach it. It's a conditional loop. It's based on a condition being true and not on us reaching a particular count. So we'll leave that one as a while loop. You'll sometimes see people try to force a conditional loop into being a counting loop. It's possible, sort of, but a really bad idea because the loop header will be telling a lie. It will be pretending the loop executes a fixed number of times when really it's executing based on a condition. A while loop is the more powerful loop, and you can always write a while loop. A for loop is a great choice for readability when your loop is controlled by a stepper or counting variable. Now, something I've done with this loop is I've declared the variable I in the for loop header. You will often see people do that if the variable isn't needed before or after the loop, and quite often it isn't. In this case, we don't need I in the code before or after the loop, so we can declare it in the loop header. And then the scope of the variable is the loop body itself. Scope means visibility, or where a name is defined, where you can use it. Look what happens if I try to assign a value to I after the end of the outer loop. I'll type I equals 10. And Eclipse immediately gives me a red X, and if I mouse over, it says I cannot be resolved to a variable. What, you might think? It's right there at the top of the for loop, but it's no longer declared. So that is an important thing to remember. Now, another thing about this loop, you usually don't want to modify the loop control variable within the loop. But here we're modifying it within the inner loop, which is a while loop. And we're modifying it in a way that makes sense for this problem. We're continuing to proceed in increments of 1 toward the end of the string. If you do this, make sure it makes sense for the problem you're solving, and not that you're doing it because you're trying to write a for loop when you should be writing a while loop. To summarize, choose a for loop when the program state, the variables, contain information about how many times the loop will execute before execution reaches the loop header. A for loop is a good choice under these conditions because it is readable. All of the loop control information is contained in the loop header. The syntax is for, open paren, initializer, semicolon, test, semicolon, updater, close paren, with the loop body enclosed in curly braces. The first time the loop header is reached, the initializer and test execute. Each time the header is reached after executing the loop body, the updater and test execute. As usual, I have included some auto-graded exercises in the description of this video, so you can practice with the video code, and the code has been uploaded to my GitHub repository. When you're feeling confident with the concepts in this video, you're ready to move on. As always, have fun and keep coding.